All right, today we're going to talk about how to multiply and divide rational expressions. Good news, compared to this with adding and subtracting, we don't have to find common denominators because you don't need a common denominator in order to multiply. So when we multiply, we need to multiply straight across the top, straight across the bottom. So do not cross multiply here. A lot of people teach that, but that is only when you have something equal to another thing. So a fraction equal to another fraction. Then you cross multiply. So please don't get that mixed up. Multiply straight across the top, straight across the bottom. So the easiest way to do this, truly, is to break everything down as far as you can into factored form. Look for greatest common factors in everything and start with that. So for example, I have 2x and a positive 4. That has a greatest common factor, or GCF, of 2. So I'm going to take that out, and I'm left with x plus 2. 2 times x gives me 2x. 2 times 2 gives me 4. So I factored out a 2. Divided by x squared minus 25. Difference of two squares, so this is x plus 5 times x minus 5. And then we're multiplying this by x squared minus 5x minus 50. I need two numbers that multiply to give me a negative 50, but add to give me a negative 5. So this would give me x minus 10 and x plus 5. Negative 10 times 5 is negative 50. Negative 10 plus 5 is a negative 5. So this is correct. All divided by, now here we have to be careful. This is 4x squared minus 16. And you're thinking, oh, I have two terms. It's separated by a minus sign. Hey, this is difference of two squares. And you're right. And you're thinking, oh, 4 is a perfect square and 16 is a perfect square. This is 2x plus 4 and 2x minus 4. You're not wrong, but look for GCF first. So this does have a greatest common factor. And if I take this greatest common factor out, what I really have is this 4 that was factored out, and I'm left with x squared minus 4. Do you see that? And so then this 4 comes out here, but this x squared minus 4 can be factored as difference of two perfect squares. And so I would get x plus 2, x minus 2. Now, if you did not do this step and you just went straight to here and you got 2x plus 4 and 2x minus 4, that'd be fine, but you'd have to factor out a 2 in each set of parentheses. So a 2 from this and a 2 from this, and that's where you would get the 4. You get to the same place no matter what, but there might be harder steps later if you didn't catch that in the beginning. So look for greatest common factor first. Now we're close to being done, but we're not quite done. We need to multiply straight across the top, straight across the bottom. Numbers. Multiply numbers on the outside with any other numbers on the outside, which are none here. So I'm going to bring this 2 down. And then connect all the factors together. And just leave them in order. So x plus 2 times this x minus 10 times this x plus 5. So I didn't really change anything. When we're multiplying, we're just going to leave it. Now we are not going to go through and distribute all that. We're going to leave that here for a moment. Now let's multiply all the bottom numbers. Or bottom factors. The number on the outside, this factor of 4, I'm going to bring this out in front. And I'm going to write these in order that I see them. So x plus 5, x minus 5, x plus 2, x minus 2. Okay, now we want to reduce or simplify or see if something cancels out, really simplifying out, because anything divided by itself is 1. Now let's start with the numbers on the outside. 2 over 4. If I just gave you that fraction, hey, what is 2 over 4 reduced to? You would say, oh, that's 1/2. And so that still is 1/2. So 1/2. We don't really write a 1 on top. We're going to erase that here in a moment. Now, x plus 2. Does that simplify out with anything in the bottom? It does. So x plus 2 will simplify here. This divided by this is 1. So those are gone because we don't normally write a 1 in its place. Anything else simplify? X minus 10? Nope. What about x plus 5? Yes. X plus 5 divided by x plus 5 is 1. Now, the only thing I have left over in the numerator then, after I simplify this out to be 1/2, is this x minus 10. So we don't need this 1 here as a placeholder. We just need x minus 10. You don't have to put in parentheses, but you can if you want. In the denominator, we have this 2, and then times this x minus 5. So parentheses, x minus 5. Please do not get cancel happy. 10 divided by 5, we don't magically get like, oh yeah, that's x minus 2 or anything. So don't get cancel happy. Only if the entire factor can simplify out, that's where we would cross those out. We don't simplify that and say, oh, 10 over 5, that's 2, and oh, the 2's cancel out, oh, the x's cancel out, hey, it all equals 0. So be careful there. Now, we do need to find domain restrictions. And we're not going to talk about holes and asymptotes yet and the difference, but what we're saying is this is our final answer after everything was reduced and simplified out. However, domain restrictions, looking at the bottom of the fraction, even those things that we did get rid of, we need to figure out what values of x can we not have. So even though x plus 5 was taken out, we know because of that from the very beginning, I can't have a negative 5 because a negative 5 plus 5 is going to give me a 0. Remember, you always take the opposite. So if I took x plus 5, set it equal to 0, and solve for x, after I subtracted 5 from both sides, I'd get that x cannot equal a negative 5. Here, x cannot equal a positive 5. Here, x cannot equal a negative 2. And then finally here, x cannot equal a positive 2. So we actually have 4 restrictions. We have 4 factors or 4 sets of parentheses in the bottom. Now, in the very end, we only have 1 restriction that we can see, where x cannot be equal to positive 5. That, eventually, we're going to learn is called an asymptote, where these other 3 that were simplified, oh, I made a mistake. Did you see that? X minus 2. I forgot that. Silly goose. All right, well, that doesn't change, but this changes. So this would be x minus 2. What happened was I could hear you from home. You were yelling through the computer screen, and you're like, Reininger, you idiot. You have this, and you brought that down. You just left it all by its lonesome. And I heard you, and I appreciate you telling me that, because if you wouldn't have yelled at me, I would not have known to put that down there. So we have 2 asymptotes at positive 5 and positive 2. What happens with these other 2, negative 5 and negative 2, we're going to learn that those are holes in the function. And we'll see what that looks like on the graphing calculator later. All right, number 2. Let's see if we can do this without a mistake. Go Tigers. See, even math teachers make a mistake. Weird. Number 2. First step, I want to factor everything as much as I can. However, this looks a little different because it's being divided by. Now, instead of dividing by a fraction, remember we can multiply by its reciprocal. So what we're going to do is we're not going to divide by this fraction. We're going to change this to a multiplication problem. So we have 6x squared divided by 3x squared minus 27. Instead of dividing by a fraction, I'm going to multiply by its reciprocal. So times x squared minus 2x minus 3 comes to the numerator. And then 2x plus 2 goes to the denominator. So instead of dividing by a fraction, we can multiply by its reciprocal. So now, all you have to remember is when you see a division sign, flip the second fraction. It has to be the second, not the first. Flip the second fraction, and now it's the exact same as our original multiplication problem. So this from here is not too bad, but we need to find all of our factors. So 6x squared, that can't go anymore, so we're just going to leave it as 6x squared. However, the denominator, I have this 3 and this 27. That has a greatest common factor. So if I take a look at that 3 and 27, if I factor that 3 out, I get x squared minus 9. Now when I see that, I realize, that's a difference of 2 squares. So down here we have our 6x squared from the numerator, just pulled down. In the bottom, though, I have this 3 times the x squared minus 9. Well, difference of 2 squares says that this is x plus 3 and x minus 3. Okay, 6x squared could not reduce, so I brought that down. 3x squared minus 27 has a common factor of 3. I factored that out, and I was left with an easier to see difference of 2 squares, x squared minus 9, so x plus 3, x minus 3. Times, because we changed this from a division problem to a multiplication problem. When I factor the numerator, there's no GCF here. I need 2 numbers that multiply to a negative 3, but add to a negative 2. So my numerator is going to be x minus 3 times x plus 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. and this is all divided by, I do have a greatest common factor here. A factor of 2 gets factored out, and I'm left with x plus 1 right here. So finally, when I multiply everything together, all the numbers that were factored out come out in front. So I have in the numerator 6 times x squared times, remember we multiply straight across the top, straight across the bottom, and I'm just going to write my factors, x minus 3, x plus 1. In the denominator, I have a 3 being multiplied by a 2. So these two numbers were factored out. 3 times 2 is 6. And then now I'm going to write my 3 factors left over. So 6 times x plus 3, x minus 3, and then finally this x plus 1. Okay, finally, let's see what happens here. What simplifies out, what doesn't? We have 6 being divided by 6. Anything divided by itself is 1, so those are gone. X squared, I have no x's or x squareds that I factored out, so there's nothing that can reduce there. This x minus 3, though, I can factor or simplify those, so take those out. And then finally, this x plus 1, divided by an x plus 1. So the only thing I have left over is in the numerator, I have an x squared. In the denominator, I have an x plus 3. And this is my final answer. So after you reduce everything, factor everything out, flip the fraction, multiply, reduce, simplify, whatever you want to call it, this is all we get down to. Go Tigers. However, remember domain restrictions. In this case, we have 3. 1, 2, 3. So yes, even though those two simplified out, it's what is called a hole. So those create holes. This is a vertical asymptote. So we have 3 restrictions. X cannot be equal to negative 3 here. So it cannot equal negative 3. It cannot equal a positive 3. And here, it cannot equal a negative 1. So those would be my 3 domain restrictions. Next, we're going to talk about how to know the difference between a hole and a vertical asymptote, and we're going to have to write that difference. But I hope you'll find multiplying and dividing is not as challenging. Sometimes it takes a lot more work and room and a lot more steps. But if you're good with factoring, then you should be okay with multiplying and dividing rational expressions.